Hey students, this video is going to go over drawing Lewis structures. Now, before we begin, I just want to let you know that I got you a little present. So, I'm not sure where you're at. If you are at your desk, maybe a present's under your chair, under your desk, under your kitchen table, underneath your bed, but reach down and grab it. I got you a nice bucket. This bucket is very, very special. First off, my bucket is fabulous because it is zebra print and it has some hot pink trim on it. It's metal. It looks beautiful. But our buckets are very, very special because their job is to hold valence electrons. They have a very, very important job. They hold valence electrons. When you're drawing Lewis structures, it's very, very important to fill your bucket, meaning count your valence electrons and put them in your bucket. So that way you know how many valence electrons you have to work with to draw your Lewis structure. So we're going to be on page 6 in your packet. We're going to go over how to draw these Lewis structures. So first thing is the bucket. Like I said, it's very, very important. This is the most important step of drawing your Lewis structures. If you don't fill your bucket with the valence electrons, chances are you will draw your Lewis structure incorrectly. So fill your bucket. So we're going to be drawing a Lewis structure for NBR to start with. So we want to fill our bucket with the valence electrons. So nitrogen, when you look at the periodic table, nitrogen has 5 valence electrons and bromine has 7. There are 3 atoms of bromine, so that makes it 21. So we have a total of 26 valence electrons to draw in our structure. This is very, very important. Step 2 is the skeleton. You need to figure out which element goes in the center. So if you have a carbon, that should always go in the middle. Typically, you can go based off of the rule that whichever one is least electronegative can go in the middle, except for hydrogen. Hydrogen will never, ever, ever go in the middle because hydrogen, being in the first energy level, can only form one bond. It can only have 2 valence electrons. Everything else can have and should have up to 8 valence electrons. So this odd man out, that's a good rule to follow also. If you have something that you only have one of, chances are that's going to go in the middle. So NBR3, N is going to go in the middle. We're going to connect everything else to it with a single line. So we'll connect all of the BRs to it with a single line. It doesn't matter which sides you put them on. If you wanted to put one on the top, that's fine. Just make sure everything is connected to it by a single line. A line is going to represent a single bond. In a bond, remember from the previous PowerPoint presentation, a bond is a shared pair of electrons. So since the line represents a shared pair, a line represents 2 electrons. So when we drew this skeleton here, we drew 6 electrons. And we would subtract out 6 from our total from 26. So now we have 20 electrons left. Now I want you to redraw this skeleton in step 3. I'm just going to be lazy and I'm just going to move my picture. So step 3 is the outsiders. Step 3 is the outsiders, meaning we want to make the outside atoms happy by getting them up to 8 valence electrons. So we're going to put dots around all of our exterior atoms, the outsiders, to get them up to 8, except for hydrogen. Hydrogen will never get a dot. Never get a dot. Because once you connect hydrogen to a line, it already has its 2 valence electrons and it is already at a stable configuration. So each of our bromines currently just has 2 electrons to it, so we need to add 6 more dots to each bromine. Notice I'm going to do this 2 on each side to get each bromine up to 8. So that means I've drawn 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons I'm going to subtract from my total. That means I have 2 left. Step 4, redraw this on step 4. Again, I'm going to be lazy. And you won't have to do all of these steps separately in the future, but this is just for learning purposes. Step 4 is our leftover step. Step 4 means we are going to put our leftover electrons on our central atom to get it up to 8. So we have 2 electrons left over, so we're going to put 2 dots on hydrogen to get them up to 8. We subtract 2 there, so we have 0 left. Okay, now I did say that step 1 was the most important step, counting the valence electrons and putting them in our buckets. That's the most important step. Step 5 is the next most important step. Don't forget step 5 to make sure everything is happy. Okay, so once you think you're done, once you've run out of electrons, look at your structure and make sure everything has the required amount of electrons. So this bromine here has 2, 4, 6, 8 electrons, because don't forget the line is 2. The bromine down at the bottom has 2, 4, 6, 8 electrons. The bromine on the right has 2, 4, 6, 8 electrons. The nitrogen, 2, 4, 6 in the lines plus 2 electrons has 8. So everything is happy. If things aren't happy, then that's where we have to make double and triple bonds to get the central atom to its 8 valence electrons. Okay? So let's look at our next structure, which was the COCl2. So again, the most important step, the bucket. Make sure you count your valence electrons. So we have carbon, oxygen, and chlorine. Carbon has 4 valence electrons. Oxygen has 6 valence electrons, and chlorine has 7. There are 2 chlorines, so we'll times 2, and that's 14. So that means we have 24 total valence electrons to put in our bucket. Okay, 24 valence electrons. We have to use everything in our bucket, and we can't use any more. Okay, so now we're going to draw our skeleton. We got to see which atom goes in the center. We're going to put carbon in the middle. It's the least electronegative. It's furthest to the left on the periodic table. And so everything else gets connected to it with a line. Now, whenever I draw it, I do try to make it symmetrical. So I'm going to put oxygen in the middle here and chlorine on the opposite sides of the structure. So we have 24 electrons to use. We just drew 2, 4, 6 in our lines. So that means we have 18 electrons left. So I'm going to scroll down. You're going to redraw this for step 3. Okay. And now in step 3, we are going to put electrons on the outside atoms. So each one needs to get up to 2, up to 8. So we'll put 6 electrons on the outsides. Let me undo those ones. Those ones are silly. Okay, so now all of our outside has 8 valence electrons. We just drew 2, 4, 6, 8, 10, 12, 14, 16, 18. And we have nothing left over. So we have nothing for step 4, but don't forget the second most important step, step 5. Carbon is not happy, which means we have to make carbon happy. So can we do this? Hang on. Can we do this to make carbon happy? No, we had nothing left in our bucket. We used up everything in our bucket, so we can't do that. So at this point, we have to make a double or a triple bond in order to make our central atom happy. To make a double bond, you have to take a pair of electrons away and create a second line in between the central atom and one of the other atoms. So which one are we going to use? Are we going to use a chlorine or are we going to use an oxygen? So really quick, I'm just going to show you why we're going to use the oxygen. If you remember when we were drawing our Lewis structures during the electron unit, oxygen has 6 electrons. So it looked like this, something like that. Chlorine had 7. And it looked like this. So that means that the chlorine really only has 1 available site left for bonding because it was missing 1 valence electron. whereas the oxygen has 2 sites available for bonding, which is why we're going to make oxygen have the double bond. So what we need to do is we need to take a pair of electrons away from the oxygen. Oops, didn't mean to take away all of those. Let me put those, oops, let me put those 2 back here. So we took a pair away, and we're going to draw a second bond between the carbon and the oxygen like this. So now the carbon still has 2, 4, 6, 8 because it has a double bond, and the chlorines each have 2, 4, 6, 8 electrons around the chlorines. And then when you look at the carbon has 2, 4, 6, 8 electrons around the carbon. So everything is happy. Everything has its 8 valence electrons. We're good to go. With our last example here, we have what's called a polyatomic ion, sulfite ion. So there's a list of your polyatomic ions on the back of, on page 2 of your packet. The polyatomic ions are going to become really, really important in our next unit, which is ionic bonding, and they're going to continue being really, really important. So we need to make sure we know how to find our polyatomic ions, how to look at those, how to read those polyatomic ions. When you see something that ends in an ite or an ate, that means it's a polyatomic ion. All of our covalent molecules end in ide, IDE, remember. So sulfite ion is SO3 -2, and you can look that up. So first off, we have to count our bucket. Remember, that's our first most important step. So when we have sulfur and, oops, sorry. We have sulfur that has 6 valence electrons, and we have oxygen that has 6 valence electrons, but we have 3 of those, so that's 18. So that's a total of 24 electrons. But what does this -2 means? It means that it gained 2 electrons. So it has 2 more electrons than that. So we actually have 26 total valence electrons. All right. So our second step, remember, is to draw our skeleton. Decide what's going to go in the center of our structure. Since sulfur is by itself, we're going to put sulfur in the middle, connect everything else to it with a single bond. Again, it doesn't matter how you arrange it. If you want to put one down at the bottom, that's fine. We have 26 electrons total to use, and we just used how many? 6. So we're going to subtract out 6. So that means we have 20 left. So recreate that for step 3, the outsiders. So we're going to put these electrons around the outside of our structure to make the outsiders happy. So we have 2, 4, 6, 2, 4, 6. They only need 6 dots because each one's connected by a line that represents 2 electrons. So that means that we just used 18 electrons. We've got 2 left. So our next step, recreate this for step 4, the leftovers. Our next step means that we are going to put the leftovers on our central atom. So we'll put 2 dots on our central atom because we had 2 left over. -2 means that we used all of our electrons. We have nothing else to use. So we want to make sure that everything is happy. Check to make sure everything has 8 electrons around it. Don't forget to do step 5. So we've got, for our oxygens, we have 2, 4, 6, and then 8. For the line, we have, for our central atom, we've got 2, 4, 6, and then 8 for that lone pair. So we're good to go. Now, if it's a polyatomic ion, we have one more step that we need to do. We need to put brackets around this structure and a -2 charge, okay? Indicating that it has a charge to the overall structure itself, okay? Now, I want to show you one more thing, and that's called resonance. So we're going to go ahead and draw something here. Let's go ahead and do nitrate, NO3 -1. Okay. First, again, count your valence electrons, most important step. So nitrogen has 5, oxygen has 6 times 3 equals 18. So that is 23 valence electrons, but because this is an ion, it has a -1 charge. That means it gained 1 electron. So we have 24 total valence electrons. When we draw our skeleton and decide what's going to go in the center, we're going to put nitrogen in the middle. It's least electronegative, furthest to the left. Never put hydrogen in the middle if you get something with hydrogen. And connect everything to the central atom with a line, and we use 6 electrons. So we have 18 left. Remember, we're going to go ahead and put and make the outside atoms happy first by making those up to 8 valence electrons. So we'll put 6 dots on each of these oxygens. And we just used 18 electrons. So we have nothing left. So then, don't forget step 5 and make sure everything is happy. Is everything happy? No, because the nitrogen is not happy. The nitrogen only has 2, 4, 6 electrons in the bond. We have nothing left in our bucket, so we can't put any more dots on the nitrogen. So that means we have to take a pair of electrons away and make a double bond, which we can do just like this. Now the question is, does it matter which one we make the double bond to? Which oxygen? No. Since it doesn't matter and that double bond could exist between the oxygen on the left, the right, or the bottom, we indicate resonance. And resonance just means that we show that the double bond could exist in any location by making a dotted line in the other locations where that double bond could exist. So we have 2 solid lines over here to indicate the double bond, but then the rest of them are dotted lines to indicate the double bond could be here or it could be here. Doesn't really matter. With resonance, we also want to put brackets around any resonance structure to indicate that it had resonance. This one we get brackets anyways because it has a -1 charge. Don't forget that charge if it's an ion. Okay. If you have any questions about drawing Lewis structures, please let me know. This is really important to understanding our VSEPR shapes, which we're going to go into in the next unit.